Okay, so we're going to talk about stored energy, okay? And to talk about stored energy, we are going to ask ourselves a question. Let's ask ourselves a question here, okay? Where does kinetic energy come from? We just talked about kinetic energy, right? And anytime you say motion, you think kinetic energy, right? Anything that's moving, that's kinetic energy, right? Makes sense. There's mechanical and non-mechanical kinetic energy, right? Okay, so imagine a roller coaster car that's at the top of the first hill and is stopped. Oh my! Anybody ever been on a roller coaster? Really high roller coaster? You go up to the very top. Ooh, and there's a split second up at the top there where you're kind of motionless. And then what happens? What do? Whoo! You go zipping back down, right? Okay, does the car stay stopped at the top of the hill for the entire ride? No, just like I said. You get up to that point, this point right here, and there's a moment to where you're right at the very top, and then you start. What happens? You start going down again, right? Okay, and that's the question. So once the car leans over the edge, gravity pulls it down, right? That's gravitational potential energy. That's the principle of roller coasters is gravity. Gravity pulls it down. The ride's taking advantage of the gravitational attraction between the car and the earth to give the car kinetic energy and make it go faster as it falls, okay? The kinetic energy the car is receiving is coming from another type of energy called, guess what? Potential energy. Okay, so right up here at the very top, you are at the full potential energy. And then as you go down here, that stored energy becomes kinetic energy. Okay? So when you think of potential energy, think stored energy, okay? Stored energy. Kinetic energy, you think motion, right? Okay? When you think of potential energy, think stored energy. Look right here. I've got stored energy right here. What's going to happen if I let go of this ball?
It's going to jump.
Gravity's going to pull it down, right? You got the idea? But right up here right now, it is potential energy. Stored energy. Just waiting for me to drop it. Okay? Similar to the roller coaster, you get up to that point, and then it tips over the edge, and gravity starts pulling it down. Okay? So the kinetic energy the car is receiving is coming from another type of energy called potential energy. Okay. Okay, so where does kinetic energy come from? Where does kinetic energy come from? Well, potential energy is energy stored in an object due to the object's position. The roller coaster car on the previous slide had stored energy due to its height above the ground. And there are two forms of potential energy that we're going to be talking about, and that's gravitational potential energy and elastic potential energy, okay? All right, so there's two types of potential energy that we're going to talk about, gravitational and elastic, okay? Potential energy, both are potential energy. Okay, so let's look at gravitational potential energy. Look at this picture right here. What's this guy? First off, what's this guy dressed up as? Tell me.
It was army.
Looks like a soldier, doesn't it? Because you can see a weapon right there, right?
Yeah.
A rifle. Yeah, and he's got a backpack on, helmet.
Yeah.
Yeah, dressed in, looks like combat uniform. Okay, so the potential energy due to elevated position is called gravitational potential energy. So he's above the pool, right? Okay, so gravitational potential energy is stored energy, and it can be used at a later time to cause an object to move. Okay, so once the person steps off this diving board right here, the gravitational potential energy is converted into kinetic energy, and the person does what? Falls or moves, right? Fall means the same thing as move, right? If you're falling, you're moving. What kind of energy is that? He goes from up here potential energy to, when he starts falling, what kind of energy is that? There's only two kinds of energy, kinetic or potential. Which one is it, when he's falling, what is that? Kinetic, right? So he goes from potential right here to where he steps off, and that converts into kinetic energy. Okay, take a look right here. Ooh, what is this? Another military vehicle that looks like it's either being loaded on or offloaded. So work is required to elevate objects against Earth's gravity. Does that make sense? They got a big crane that's pulling this, either letting it down or either pulling it up. We don't know which. For example, work is done on the truck to elevate it off the ground. So they're pulling it up. And the amount of work done on the truck is equal to the truck's gravitational potential energy at this new height. Okay? So the higher it goes, the more potential energy it has. Okay? Does that make sense? Look here. It's on the ground. Look at the ball here. Is this potential energy? It is, isn't it? Because look, if I let go of it, it's going to drop. How about this right here? This potential energy? This is more potential energy. How about this right here? More potential energy. How about this? Even more potential energy. So the higher I go, the more potential energy it has. Okay, same way with the truck. Okay? Okay, so gravitational potential energy is determined by three factors. Three things, right? Mass, that means the size, how big it is. Gravitational acceleration, and we'll talk about that. And height, okay? All three factors are directly related to directly proportional to energy. I'm sorry. The heavier the object is, the what? The more or less? More. Here, let's write that. Let's write that in there. Let's write that in there. Okay, so the more gravitational potential energy. So gravitational acceleration. So the larger the G, you ever heard that term? You're doing 5 Gs. The more, listen, gravitational acceleration. The larger the G, the more gravitational potential energy the object has. Since gravity on Earth is considered a constant, we'll talk about that. It's 9 point something meters per second. We'll talk about that here shortly. And then the height. The higher the object is off the ground, just like the ball, what? The higher the what? More or less? More. So all three of these are more, right? Three factors. The gravitational potential is determined by three factors: mass, gravitational acceleration, that's how fast it's going to fall, and all three, and then height. And all three are directly proportional to energy. Okay? Makes sense? Okay, so let's look right here at this. We're going back to the tennis balls as when we were talking about kinetic energy, right? So you can talk about tennis balls in the context of potential energy as well. Okay? So how does mass affect gravitational potential energy? Mass is the size, right? How big something is, how small it is. So in this picture, the mass of a tennis ball was doubled when it was at the same height off the ground. Okay? Doubled. Okay? Okay, so mass here is the mass is 2 kilograms. Mass, here's 1. So how does the gravitational potential energy compare for the two objects? Well, let's find out. Look right here. The mass doubled. Gravitational acceleration stayed the same. And then the height stayed the same. There's no change, right? Okay. Okay, so let's look right here. Okay, so in this picture, a tennis ball is lifted to the height that's twice as high. Look right here. twice as high, so it's gonna double, right? So how would the gravitational potential be compared to the higher height? It's gonna double. It's gonna go from 2 to 4. Make sense? Okay, so, how does the height affect gravitational potential energy? Now, let's look here. Okay, so how does mass? Mass is doubled, right? No change here and no change there. So the only difference here is the mass doubled. Okay, look at this one. So how would it compare to the higher height? Well, the mass stayed the same. The gravitational acceleration stayed the same, but the height doubled, right? From 2 to 4. Okay, so here's a question for you here. You got your copy up, you got it open in Cami, and you're ready to write your answer?
Yeah.
Okay, so let's write an answer here. Okay. It's okay to be wrong, it's not the end of the world, so just do the best you can on this. Okay, so a bowling ball which has a mass that is 30 times larger, it's 30 times larger than a softball, okay? Bowling ball is 30 times larger than a softball. It's lifted to the same height as the softball. So how does the gravitational potential energy of the bowling ball compare to the softball? Is it going to be the same, 30 times smaller, 10 times as large, or 30 times as large? It's okay to be wrong, just mark you an answer. We'll talk about it. Based on what we just said. The mass is 30 times larger. It's lifted to the same height. So how does the gravitational potential energy of the bowling ball compare to the softball? Are they the same? Are they 30 times smaller, 10 times as large, or 30 times as large? Mark your answer. I'm moving on here. Okay, 2 balloons are floating in the air. Ooh, they're just floating in the air, right? If one balloon is floating at a height of 30 meters, that's about 100 feet. And the other identical balloon is floating about a height of 45 meters. That'd be pretty close to about 150 feet maybe. How much larger is the gravitational energy of the higher balloon compared to the lower one? Is it going to be half as large, the same, 1.5 times larger, or twice as large? Mark an answer. We'll talk about it here shortly. Okay. Okay, so we're going to add to those here. How many questions we have? 3, 4 questions? How many questions did we do? 2? Okay. Okay, so let's look right here. So we can calculate gravitational potential energy. And so gravitational potential energy equals mass times gravitational gravity times height, okay? Okay, so here we go. Okay, so a basketball, I want you to see this solution here. A basketball with a mass of 0.5 kilograms, that's about a pound, is held at a height of 2 meters. That's about 7 feet up in the air. How much gravitational potential energy does the ball possess? Yes.
I'm going to sit to the restroom under teacher.
Okay. Let's take a look right here. Uh-oh, my box isn't going to work. Hang on 1 second here. Let's see if I can make it work here. I want you to see the solution. We've frozen again. Hang on 1 second here. That's what Mondays are for. Technical difficulty. Hang on. Stay with Mr. Hughes. Okay, and then let's restart this thing. I want you to see the solution because we're gonna do some problems here later with that. Okay, and we were at stored energy. Okay, here, so here's our formula. Did I give you a card earlier? Let me give you a card. I'll give you a card. I want you to write this formula down, and if you're at home, get a sheet of notebook paper, card, whatever you have, write the formula down on it for future problems that we're gonna do, okay? Okay, let me give one of these to you. I want you to write exactly what you see right here. This is your formula. Gravitational potential energy equals, that's what the GPE is. Gravitational potential. Huh? Yeah, it's pencil class. It's your responsibility to bring a pencil. I got pencils today. You got a pencil, Sophia?
Yes, I do.
Good. Okay. Okay, so let's write this formula down here. Gravitational potential energy, that's what this means. Gravitational potential energy. You see that right there? Okay, equals mass times gravity times the height. Mass times gravity times the height. Mass times gravity times the height. Okay? And then we've got two numbers that we're dealing with in the problem here. 0.5 kilograms, and that's the mass, right? And then it's held at a height of 2 meters, that's this right over here, height. So where did this come from, this gravity? Well, in every instance, if you live on Earth, everybody live on Earth?
No, I live on planet Universe.
Well,
Planet Zinguatla.
you're on Earth right now in this classroom, so anytime that you live on Earth, the gravity is always gonna, this formula, this number right here, 9.8 meters per second squared. Okay? 9.8 meters per second squared. Okay? And then if you calculate that, let me give you a calculator. Or you can use, if you have your own calculator, that's fine. You can use mine or you can use yours. Okay. Okay, so this is a pretty simple problem here. Look here, so you take your 0.5 times 9.8 times 2 equals, and don't blurt an answer, show me your answer. You got an answer? I wanna see your answer, don't blurt the answer, I wanna see your answer. Good job. And remember the unit is what? What's that J stand for?
Joules.
Joules. Let me show me your answer. Got an answer for me?
No.
You use the calculator, your personal calculator, okay?
So wait, what's the problem again?
Okay, look. So you're going to use your calculator, you're gonna take 0.5, don't forget to use your 0.5 times 9.8 times 2. And then equal on your calculator. And you should come up with this answer right here. Okay?
Okay, so yes, I did come up with it. That's cool.
That's the formula. That's the way you, now, in other problems, this number's gonna change and this number's gonna change, but look right here. This number, gravity's always gonna be the same. You just put that in your head. Just understand that if you live on Earth, gravity pulls you toward it at 9.8 meters per second square. Okay, always. It pulls everything toward the center of the Earth, 9.8 meters per second square. Now, if you lived on Mars or the Moon or something, it'd be a different number. But this number on Earth is always going to be the same, 9.8 meters per second square. These other two numbers are going to change. This one will always be the same, gravity. Gravity's always going to be the same number, 9.8 meters per second square. Mass, just so you understand, this is mass, this is the gravity, right, the G, and this is the height, okay, mass, gravity, height. Gravitational potential energy equals mass times gravity times height. Gravity is always going to be the same number. Mass is not going to always be the same number. Height's not going to always be the same number. But gravity will always be the same number, 9.8 meters per second square. That's a gimme right there, okay? Okay, I bet you guys are ready to do a problem now. And now this I want you to do on your, you can do it, use your calculator, but I want you to write the problem on the document itself, okay? For the next problem that we do, I want you to write it on the document itself. You can either type it in there, or write it, draw, use the writing tool, the drawing tool, or you can use the text box, okay? 0.5 times 9.8 times 2. This is going to change, this is going to change, this is always going to be the same. Okay, I'm going to move on here. Everybody, you got that, Iris, are you done? Sophia, you're still writing? Okay, I'll give you a couple seconds here.
Okay.
Okay, let's see if we got a problem right below. Okay, so here we go. Do you remember what our formula is, right? You remember what our formula is? Okay? Okay, so here we have right here, this is number 23. I want you to do this. You can do this on your card or whatever, but I want you to also do it on your, I want you to also do it on your document, okay? You can either use the text box, you can draw it, doesn't matter to me. Okay, so here's our formula. Well, let's read it first. A 50 kilogram diver is standing on top of a 10-meter platform. How much gravitational potential energy does he have? Okay, so you remember what your formula is, right? GPE equals whatever the mass is times the gravity. Gravity's going to be the same number times the height, right? Okay, so GPE, gravitational potential energy, equals what? What is it? Mass times gravity times the height, right? So what's our mass for this guy right here? 50 kilograms, right? Times what? Times what? Times what? 9.8 meters per second square times what? 10 meters, right? Okay. Okay, now that's gonna be a lot bigger number than what you just had, right? Cause this is a lot bigger, lot more mass. 1 pound versus about 120 pounds. And then 2 meters versus 10 meters, so that's gonna be a lot bigger number. But now you know the answer is gonna be GPE equals something joules, right? We measure energy in joules. So, you got an answer? If you got an answer, show it to me. I don't want you to blurt an answer, show it to me. For the students at home, they're gonna get their own number. And who's got an answer for me? I like that number. You got a number for me already? You got a number for me, Daniel?
Yes.
Okay, so you're gonna take 50 times 9.8 times 10 equals, you got a number for me, how's that? 50 times 9.8 times 10. That's a formula. Remember I said in math for science,
Oh, I got it.
I'm more interested in you knowing the formula. Good job. Good job. I'm more interested in you knowing the formula, and you do need to know the formula. Because the numbers are gonna be different in every problem. So, and that's kind of math in general. You need to know the formula. It's not so much about getting the answer as it is knowing how to get the answer. Okay, I'm gonna leave that there for now. We will talk about this, later, okay? Everybody got your answer? Anybody not have your answer yet? Did you show me your answer, Sophia? I don't want you to blurt your answer, I want you to show me your answer.
So typing.
Hmm? Okay, if at home you're going to do the same thing that these students are doing here, you should have this on your document. You're gonna take your calculator, you're gonna multiply 50 times 9.8 times 10. And you're gonna put that answer right there, and it's gonna be measured in joules, because energy is always measured in joules. Okay? Okay, about 30 more seconds, Sophia. 50 times 9.8 times 10, show me your answer. Good job. Okay, so I'm gonna erase this. Let's erase this and let's move on. We probably got another problem. There it is right here. Oh my, now look at our number here. Look at our number here. Can you imagine the number we're gonna get? We just went from 0.5 to 50 to 3,000, so we're gonna have a huge number. I'm talking a huge number. Okay, so, you know, GPE is what? Make sure you got your formula. GPE equals what? Mass times gravity times height. And we know that the gravity is gonna always be the same. The mass is 3,000, oh my, that's a big number. 3,000 kilograms times what? Times what here, Iris? What's my gravity gonna be? 9 point what? 9.8 meters per second square times what? Times 100 meters, right? Woo, that's gonna be a big number. Okay, and your GPE is going to equal something. Oh, that's gonna be a big number, joules. Okay, does that make sense? Okay, this is the one I'm gonna help you on here, you're on your own for the next one, but I'm gonna help you out with this one here. Don't blurt out an answer, but I want you to give me an answer. Oh, that's a huge number. That is a huge number, show me your number. You got that number right there, don't worry about the answer, just show me the number. Okay, it's gotta be bigger than that. Let's see. Put it on this calculator right here. 3,000 times 9.8, that's a huge number, dude. Let's see here.
9.8
Hmm?
times 100.
I have, let's see here, 3,000 times 9.8 times 100 equals, that answer has 7 digits in it. 7 digits, you got too many zeros in there somewhere. And you don't have enough zeros. 3,000, be sure you, look at your calculator, be sure you get all these numbers, times, that's what these brackets mean, the parentheses mean, they mean times, right? $3,000 times 9.8 times 100.
I got it.
Show me your answer. Good job. Perfect. That's the answer you need to put down there, good job. That's the answer you need to put down there, good. Yep, times 9.8 times 100. Uh-oh, do it again, try it again. It's okay, try it again.
Okay. Let's figure how many minutes of bus do we have left?
Let's focus on this problem right here. Talk to me, give me an answer, you're going ahead and give me an answer yet. Show me your answer.
Okay.
Okay, everybody got an answer? I think we got time to do one more problem. Okay, I'm gonna move on, but I'm not sure if there's another problem behind this or not. No, but that, you know what, that'd be a good place to start. We're gonna stop right there. We'll start on here tomorrow, okay? We'll start here tomorrow. Okay.